In this video, we're focusing on the hyperbola. So two examples of what a hyperbola is: when you have a pizza and you start cutting slices in, the more slices you cut into the pizza, the smaller the size of each slice gets, all right? The next one is if you have workers, the more workers on a project, the less time it takes to complete the project. So if I was to quickly draw a sketch, here we have this, and I have workers down here, and then we have time here. Okay, so as we're going to the right, we're getting more workers, and as we go down, the time taken to complete the project is decreasing. So the more workers we add, the less time it ultimately takes. Okay, so that's what we're talking about. That's kind of like the hyperbola. Now, the generic shape is what you can see on your screen there, and it's given by y equals k over x, where k is what we call the constant of variation. So if we go down here and we look at a problem, so here our problem is that the more boxes a factory produces, the less it costs to produce each box. When 128 boxes are produced, it costs $2 per box. We need to find this equation. So we know the generic form is y equals k over x. Now, in terms of our actual problem, what I'm going to do is I'm going to say that our y is our money and our x is the number of boxes. So what I could change here, just to make it a little bit more personal to this question, is we could have C for cost, K over B for boxes. Okay? Now we still need to find that constant of variation, that K. And what I do is in all of these problems, you'll notice that usually in the second sentence, they give you some values. And in ours, it was 128 boxes are produced. It costs $2 per box. So what I do is I substitute those values in. So I get 2 here, k over 128. I then rearrange it, so times 128 times 128. That cancels out. And I'm left with k equaling 256. At this stage, what I need to do is re-put this back up here where the k is. So our actual equation ends up being C equals 256 over B. Okay? And from now on, that is the equation we use for the rest of this problem. Okay? You don't need to go back and find K every time. We've got it. It's 256. We're going to use that from now on. So that's our equation. Usually the next question is something like this, where it's said, all right, find the cost if 100 boxes are made. Now we know our formula is C equals 256 over B. Our B value now is 100, so let's substitute that in. So 256 over 100. So we know that the cost is going to be $2.56. So I've used that equation I found in part A. Let's go down to part C. Find how many boxes are needed to be made to get a cost of 0.5. So again, we're still using the same equation we found in A. We substitute in our values, so 0.5, 256 over B. If you remember the trick here, you just swap our unknown and the 0.5. So B is going to equal 256 over 0.5. And that ends up with 512 boxes. All right. Now we're going to sketch our graph. So what we're going to do for the first one is we're going to create a table of values. So here's a table of values that I've just made. Remember, you control the X values, so you could put any numbers in the top there. Now I picked 10, 50, 100, 200, 400, 512 because some of those I've already calculated. I don't want to really go back and redo it, but also because it gives me a really wide range of numbers. So now how we find these numbers is, let's say I wanted to find this number here, this Y value. I go in and say, well, C equals 256 over 10. So that was 25.6. So 25.6 goes in there. I then repeat this procedure to fill out the whole table. Now what I end up with is 51 point, oh, not 51, 5.12, 2.56, 1.28, 0.64, and 0.5. So a wide range of numbers there. Now what you do is you end up plotting those over here. So as you can see, I've already plotted my dots. Let's zoom in, you can see them there. And what you would do now is draw a smooth curve that tries to connect as many of them as possible. This is a sketch, it doesn't have to be perfect. So there's my sketch. As you can see, it's going through it. So as we make the more boxes, the cost for each box decreases. Okay, so the next part we're going to look at is what we call continuity. So hyperbolas are what we call discontinuous functions, and it's because there's a gap. And as you can see in this one, there's a gap pretty much going down here, the y-axis, and across here, the x-axis. Okay, so the graph never actually reaches x and y. Now, those invisible lines that I drew, so in our case, the x-axis here in blue and the y-axis here in blue, if they were straight lines, not little curves, they are what we call asymptotes. All right, so an asymptote is where a line or a value that the graph never reaches, or it doesn't exist at those points. Okay, so we're going to go down and use this skill to now do the next question. So here we have a function, fx equals 3 over x minus 2. We need to sketch it and list its domain and range. So we're going to start by quickly rewriting this, fx equals 3 over x minus 2. Now if I wanted to find the asymptote, I can find my x asymptote by finding what that x cannot be. Now I know it's the denominator, and I know the denominator of a fraction cannot equal 0. So at this point, I can just start to rearrange this. So plus 2, plus 2. So I know that x cannot equal 2. So I know that's my asymptote. Now, because there's no other things going on at the top here, my y asymptote is going to be the y-axis. All right. So I went in and quickly drew up a graph. In the greens are my asymptotes. I just realized I had the asymptote in the wrong one. So there, I've just changed it, so it's in the correct spot now. Now what I want to do is I want to find my y-intercept, because I want to know where the hyperbola is going to be crossing that point. So what I do is remember that the y-intercept occurs when x equals 0. So for our function here, over 0 minus 2, so y is going to be 3 over negative 2, which you can see I've got the little red dot over there where it's going to cross. So now that I've got all that, I can quickly sketch in my rough sketch of the hyperbola. So it'll be something like that. Okay, not perfect, but it is a sketch and you get my understanding. So now we quickly need to sketch our domain and range. So remember, the domain is all the x values. So I'll just zoom in a bit so I can write this a bit neater. So our domain is all the x values, so it's going from left. We know it goes from negative infinity all the way until it gets to 2. And then it goes from 2 all the way to infinity. And our range is all the possible y values. So the same thing all the way to 0. Then from 0 all the way to infinity.